Oh no. Oh God. Okay. Wait, have I been talking by myself all this time? Oh no, I've been talking by myself all this time. Oh God. Mm, you see, this is what happens when I don't have enough coffee. Hey, Victor. Victor, I was reading you. Guess what happened? I had the stream going on my side. I had the video, I had everything. I had forgotten to press the button on YouTube go live. So I was basically like doing my thing, blah blah blah, whatever, and there was like I was just literally not streaming. It was just blocking. This is what happens when I don't have enough coffee. You see? Hmm? Oh my God. Victor, Chandra, Andres. Well, Victor, thanks for telling me, because if it hadn't been for you, I would probably have done the whole thing and not press the button to turn on the stream, you know? Hey, Barbara, how you doing? Good to see you. What's up? Um, wow, this was dumb. This was very dumb. And 20 minutes later. Well, Victor, thanks for letting me know. That was really helpful, actually, because yes. All right, so I guess I will start over again. Um, So, where was I? Okay, so let me start over again. Three, two, one. Woohoo! Welcome. Well, Andres, yes, send me some. I would be more than happy to try Colombian coffee. My friend Olga Mesa brought me once this really nice Colombian coffee. Was it Águila? Was the brand? I believe. Is that a thing? Café Águila or Águila Café? Um, I don't know. It was really, really strong. It got me like it was so strong it was a little bad actually. Anyway, so three, two, one. Good morning. This is Jose Luis. I run this thing called Parametric Camp. We do computational design live streams. We have a Discord server that I posted on the chat twice now because I was talking by myself before, where we have offline conversations and where smart people like Victor let me know that I'm being a fool and I'm just talking to no one because I forgot to press the button to go live. And so thanks for that, Victor. And we also have a calendar where we where we where I write the events when we go live. So you can subscribe to that if you're using Google Calendar. So this week we typically stream on Fridays and record tutorials, but this week we're doing a full live stream thon because I want to wrap up this series that we've been working on for a while, which is Introduction to Parametric Modeling. So we're going to wrap that up today. And today we're going to talk about data, which is perhaps one of the topics that takes a little bit of time to wrap our heads around when we start working with algorithmic modeling, and specifically inside of Grasshopper, how data is handled and the structures that are in place to make data manipulations. So we're going to do that today. And the way we're going to do that is I'm going to start by recording a video where I'm going to walk myself into a problem that we will face very commonly, which is going to be caused by not handling data correctly. So what is that problem going to be? Well, so I'm going to fire some Rhino here. And then I'm going to, what am I going to do? So I think I would like to start the video. How am I going to start the video? I'm going to start the video by saying, so what I would like to do is I would like to say that in the previous exercise, we did the hanging cloth. So I would like to propose a new exercise, which is going to be to create a to create a to create a hanging cloth also, but with a different process. So I would like to draw in my sketch. I'm going to draw what the process, and then I would like to give people virtual time to do that, and I will try to do it myself. And I would like to record an introduction. I can probably start from the introduction and just saying what we are going to do. And should I open up with the actual piece of cloth from yesterday? Should I do that? Well, my last exercise was actually the Berlin Holocaust Memorial. So perhaps I can open this. I really don't need to. Maybe I don't need to do this. Maybe I can just start from the sketch. Or maybe I want to do that. And then if I start from the sketch, maybe if I start from the sketch, what I can do is so the sketch can be, this is one of the curves, this is the other one, and then what I do is I subdivide that curve into a series of points, and then I subdivide this into a bunch of points, and then I create lines between them, and then I find some other point in the middle. For example, I move that point up in Z. And then I create a curve between those points, something like that, and then hopefully afterwards I can create a surface. Okay. That could be an exercise to do. Or I should have drawn everything a little farther down the road. A little farther down. Okay. So what if I do that? Okay. Maybe I can start like this. Oh, and I can have maybe, can I do this? Can I just write like, can I write, okay, I'm gonna give myself a little bit of a license here, and I'm going to, wait, no. Whoa, nope, this one. Nope, it's too big there. Nope, this is too big, way too big. I'm just going to write the word data in big capital letters here. And then Oh my God, that's terrible. Is that terrible? That's pretty bad, right? You can be honest with me. I won't take it personally. Woo! Oh my God, this is so bad. Oh, and whoa, 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 whoa. Whoop, up. Da, 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 da. Da, 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 da. Oh my God, this is bad. This is very bad. Why are you letting me do this? Why are you letting me do this? Where is Nono when you need him to help you out with some drawing? Huh? Oh my God. Okay, so let me take all this stuff and center it. So can I cut this and paste it? And no, 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 no. Can I move it? No. How do I just move it? There you go. Okay. All right. So now and okay, this was okay. All right. Okay, I think we're ready. Are we ready? I think I might be ready for this. Oh God, this is not going to be go. This is not going to go well. Okay. All right, let's start. Hi, this is Jose Luis, and welcome to a new video on this series, Introduction to Parametric. Okay, so what do I want to say? I want to say the intro. I want to say that we're starting a new section. We're going to be talking about data. Okay. All right. So let's do that. Hi, this is Jose Luis, and welcome to a new video in this series, Introduction to Parametric Modeling. We're going to start a new section with this video, and in this section, we're going to deal with the topic of data. Choo-choo! Sorry for the terrible sketch. I haven't drawn things in a while. Yeah, it's been quite some time. And we're going to be spending some time talking about data because it turns out that data manipulation and data handling is one of the probably most important topics when we are working with algorithmic modeling. But at the same time, for those of us who are newer to using computational methods, sometimes data manipulation might be one of the topics that it takes a little more time to wrap our heads around in this case. So I would like to take quite some time to talk about how data is important to algorithmic modeling processes, what are the problems that we may encounter, and what solutions, what tools do we have to solving those problems. And I will use Grasshopper as a medium to explain many of those ideas, and we will take a look specifically at which data structures are available in Grasshopper to work with data. Um, get me Trust me on this one, it might be a little confusing at first, but definitely if we get good control over data manipulation, it's actually one of the most powerful tools that we can. We're starting over again. I did not like where I was going with that. Hey, Salvador, good morning, sir. Andres, are you sending me the coffee or not? All right, let's start over again. Over again. Oops, sorry, let me turn off. Hi, this is Jose Luis, and welcome to a new video in this series, Introduction to Parametric Modeling. In these videos, in this new section that I would like to start with this video, I would like to talk specifically about the concept of data. And sorry for the really bad sketch. It's been a while since I've drawn things on anywhere, but I would like to start a new section where I'm going to delve a little deeper into topics related to data, because data generation, data manipulation, and data handling are perhaps one of the most important topics when it comes to algorithmic modeling. But at the same time, for us beginners, sometimes it might be one of the topics that takes a little more time to wrap our heads around, because it's one of the most new topics. It's one of the newer topics that we have to deal with if we are new to modeling in 3D using algorithms. It turns out that this might be one of the trickiest topics, but at the same time, if we get a good grasp on how data works and how we can use it to our advantage, it's also one of the most powerful tools that we can have in our tool set for computational design. So that's why I would like to take special time and consideration in the videos that I'm going to record on this topic, in this section, okay? So in this section, I'm going to teach you how to think about data, conceptualize it, how to see it flowing through our algorithms. And at the same time, I'm going to teach you in particular how data is handled in Grasshopper, and what data structures are available there and how we can use them to our advantage. And before we go into explaining any of that, what I would like to do is I would like to explain an example, show an example of the typical problems that we're going to run if we don't handle data well. Because trust me on this one, 90% of the problems that you're going to have when you start working at a deeper level with tools such as Grasshopper are going to be related to data and data manipulation and data structures. So let's take a look first at an example of a data problem that we may very easily encounter. Okay. Okay, so how am I going to transition? I'm going to transition just smoothly. If you remember from one of my previous videos, we did an exercise that was modeling a hanging cloth. And the idea behind this exercise was just taking two input curves and then creating catenary curves between them so that we could mimic somehow this idea of a piece of fabric sagging and in its own weight. So I would like to propose that we try a very, very similar approach, but instead of using the catenary logic, the idea that the fabric deforms under its own weight, I'm going to try a new method. I'm going to propose to you that you give a try to doing the following exercise. We're going to model something very, very similar. We're going to also model that some kind of canopy that starts from two input curves that we may have in Rhino, for example. And then what we're going to do is we're going to follow a very similar process where we're going to subdivide each one of those two curves into a bunch of points. But now, instead of joining those points with catenary curves, what we're going to do is we're going to join them with NURBS curves. And for that, we're going to need at least a third point to make the nice curvature of the canopy. That third point, we might be able to generate it with a simple method, such as, for example, drawing lines between the 2 points in each one of the ends of the curve, then finding some point that lies in the middle of that line, and then taking that point and moving it Control C distance. So whatever it was, we can just move it a little bit up. And we know that moving points is basically doing like some numerical computation with their coordinates. And after that, what we can do is we can join those curves. We can create new curves by joining the first point, the other point that we elevated, and the first point of the other curve. Do that successively, and then loft a surface over those curves, and then get a nice surface. All right. It's a very similar approach. It doesn't use the physics logic. It uses some other modeling logic. It will give us like a canopy that has a constant height. And it could be super interesting. So what I would like to do is I would like you, the viewer, to invite you to try this out on your own with what you have learned so far. I'm going to give you some virtual time, so you're welcome to pause this video and give this a try. That was time passing, in case you didn't get it. All right. Hopefully you paused the video and you gave it a try at some point while I was goofing around. And what I'm going to do is I'm going to try it myself. So I'm going to go back to Grasshopper and start this exercise. And if you actually run into a problem when you were doing this exercise, that is very normal, and that's the problem that I want to run into, and that's going to be my segue into explaining data structures. Okay, let's take a look at how to do that in Grasshopper. Okay. I will be right back. Give me a minute and then we continue the exercise. Okay, where's my, yes, here. All right. Sorry. Yes. So where were? Oh, can you hear the construction? Can you hear the construction? Okay. All right. You can hear the construction. You cannot hear the construction. Okay. All right. We're going to. Okay. So I'm going to create a new thingy here, and I'm going to shut down this exercise, and I'm going to what is this file going to be called? This file is going to be called, how are we calling this video? Intro to data, let's talk data, data problems. How should we call this video? Huh? I don't know how should we call this video. Anyway, how should we call this video? Well, let's call it, I don't know, let's call it 5.1 introduction to data, for example. That is a very lame name. Okay, so I'm going to save this also as 5.1 into data, for example. Okay. All right. So what are we going to do? So we were here. I was going to, yes. So what I'm going to do is I'm going to replicate that example. I'm going to do the example that I just explained, and I'm going to run into the problem that I want to run. Okay. So Thibias, welcome. How are you doing, sir? Elangoban, are you new to the channel? Welcome. How are you doing? All right. So let's do that. Mm-hmm. Mm-hmm. Let's get started. I'm going to try to do the process myself and see if I run into any problems, right? So I'm going to create two curves here in Rhino, and then one is going to be like this, and the other one is going to be like that. And then I'm going to bring those two curves into Grasshopper. And we've already seen how to do this in previous videos. So I'm going to copy paste this one, and then I'm going to right click and set the other curve. All right. And now I have both curves here inside of Grasshopper as input data. The next thing that I'm going to do is I'm going to subdivide them into equal length points with the divide curve component. And I'm going to do one for this curve. I'm going to do another one for this other curve. And I'm also going to drop here a slider that I'm going to use to control how many points do I have on each end. Okay. Now, the next thing that I would like to do, I'm going to double click here and say 15, for example. Whoa, that was a lot. 15. Now, the next thing that I would like to do as per our sketch is that I would like to now draw lines between the two curves and then find some point that lies in the middle or at the control distance. All right, so I'm going to now draw lines between the two. So I'm going to go to curves, primitives, line, and I'm going to draw lines between the family of points on the left and the family of points on the other end. And then now, what I would like to do is I would like to find a point along those lines. We haven't seen that in any of the previous exercises, but if we go, for example, to analysis, you can see that there are a lot of different components that give us different ways of interacting or of getting data from a curve. One of them, a very common one, is point on curve, which says evaluates a curve at a specific location. So, and here, if I, for example, if I give it a curve, you can see that it gives me a point that is at the parameter 0, that is going to be the beginning for a line, and parameter 1, which is going to be the end for a line. Remember the video where we talked about curves having a domain that is typically starts at 0, although not always, and ends at whatever number, and we can use the parameter to find a point along that domain space. We could use this one, but I don't really like this component because it's kind of like halfway through a component and a slider. And I actually like to have all my sliders at the very beginning, and it's kind of like cumbersome if I bring this here, and it's also like I can't really change it from 0. It has to be always from 0 to 1, right? So I don't really like that. So I'd rather use this other one that is called evaluate curve. I like this component a little better because it takes in a curve, it takes in the parameter on the domain of that curve, so where along the curve I am, and then it gives me a lot of stuff afterwards. It gives me the point on the curve, it gives me the tangent vector, and it gives me the angle of the incoming versus the outcoming curve. All right, so what I'm going to do is I'm going to place that here, and I'm going to drop here a slider. I'm going to type 1.000 to get a slider from 0 to 1 with 3 decimals, and I'm going to plug that in here. And you can see that now by moving this slider, I can find a point at a relative length from 0 to 1 for lines, because remember, straight line segments are the exception of the curves, and we know that straight line segments always have a domain that goes from 0 to 1. All right, and I have my parameter here and all my inputs. You know how I like having my inputs at the very beginning. Let's make sure that I group them properly here, and that keeps my OCD very happy. And now what I would like to do is I would like to say, well, I would like to elevate all these points a particular distance z. So I'm going to create another parameter that is another slider that is going to be the height. That's going to be, for example, 10.000. And then what I'm going to do is I'm going to take all these points, I'm going to deconstruct them so that I can find their x and y locations. And then to the c location, to the c coordinate, I'm going to add the height that I just created. So I'm going to drop here an addition component. I'm going to the c height of those points. I'm going to add the height that I just created. And then I'm going to reconstruct a whole new family of points with the same x, the same y, but the new c with the increased height. Can you see that? And then I can control how high or how low those points is. I'm doing that as increments because if I were to change this curve, for example, and move the point a little higher, you would see that the points here are not planar anymore, are not on the same plane. So I would like that to be mimicked here on the top. All right, so I think we're ready, right? So let's take a look at this first. So now the only thing that we have to do left as per our sketch is to take those points, the points on the left curve, the points on the top of the canopy, and the points on the right end, and join them with an interpolated curve, for example. So where are those points? So those points are going to be here. These are the points on the left-hand side. These are the points that I just created on top. And just for the sake of clarity, I'm going to disable everything else, and I'm just going to keep the 3 families of points. So that's how the points on the left, the points on the middle, and the points on the right. And just to make it a little clearer, I'm just going to pass them through empty point boxes. All right. And just to have them a bit clearer. So first family, second family, and third family of points. All right. So I have the 3 families of points here. And now what I would like to do, and just to make sure I'm going to put a panel and take a look at what's going on. Here I have a list of points, all of them with 0 coordinates. Here I have a list of points, all of them with a very large y-z coordinate. And all of these are the points on the right. All right, so then at this point, creating these curves, the blue curves, should be just as easy as going to the curve, going to splines, and then, for example, choosing interpolate to create an interpolated curve through the set of points. So what I'm going to do now is I'm going to say, well, I want to create a curve between the first family of points. I'm going to plug that in. Then between the second family of points, the one on top. So I'm going to drag this and pressing Shift to add to the component. And then, oh, something is not working well. And then I'm going to add the third family of points, pressing Shift so that I add them to the list. Oh, and this is not what I expected. You see what's going on here? Let me highlight this. You see the green curve? The green curve is, as opposed to what we wanted, which was several curves, each one of joining the first point, the first point, and the first point, and the second point, the second point, the second point. Instead of that, what we ended up with is with one single spline that went through all the first points, then all the points in the middle, and then all the points on the right hand side. And we can also see that by putting a panel here and seeing that the output is just one single curve. So what happened here? Why is the component behaving this way and not the way that I expected, which is individual curves joining this point, this point, this point, this point, this point. Long story short, we have data problems, okay? And as I was saying before in my introduction, 90% of the problems that you're probably going to run into when working with Grasshopper, for example, and when getting results that don't match your expectations are very, very likely going to be caused by some kind of misconception or some kind of problem about how data has not been handled correctly. Okay? So, all right, so then what is the problem that is going on and how do we solve that problem? Before we get into that, I would actually like to take a break and move on to the next video where I would like first to define some concepts that relate to data and specifically data structures inside of Grasshopper. I would like to lay down some foundations and some concepts, and then once we have those clear, then we can come back to this video and to this exercise and see how we could fix our problem and then get the desired result that we wanted. Okay, so let's put a pause here. Let's put a pin on this one, and let's go into the next video where I'm going to explain data structures in Grasshopper, what they are, how they work, what are their main elements, and then what kind of operations can we perform with those. And then we will be able to come back and fix this problem. See you on the next video. And if you like what you're seeing so far, maybe consider liking this video, subscribing to the channel, turning on notifications, etc., etc. It helps us keep the ball moving, okay? See you on the next video, and let's talk about data structures. All right. Victor, does evaluate curve and point on curve always output the same point? I remember someone said they don't. I don't think they do, because if you use, for example, let's say that you have this curve, right? If you evaluate that curve, if you say point on curve here, that one is going to be the first point, the middle, and the end point. However, if you use evaluate on this curve, you're not going to get the same result, because, for example, if I copy this slider and I query this curve from 0 to 1, you can see that the point that I'm getting is not even close to the end. Okay? That is because the domain of the curve, so what is the domain of the curve? If I look at the domain of the curve, you can see that this curve has a domain that goes from 0 to 55. So asking for a point at parameter 1 gives us a point that is really, really at the beginning. Whereas this component, what it does is it reparameterizes internally the curve so that the parameter space goes from 0 to 1, and then you always get the point at the beginning and the point at the end. So it kind of hides away from you the fact that it's reparameterizing the curve. However, if you reparameterize this one, I believe that you should get the same result. So for example, yes, you start at 0, this is somewhere in the middle, and then you end here. All right. So for example, let's try this out. So 0.8 would be this point here and here. If we do, I cannot double click, I cannot set the point. Wow, that's kind of not nice. So 0.8 will be a point that is very, very close. You see? Both points are very close to each other. Actually, they're not very close. That's kind of weird. Interesting. Maybe this is point on curve is actually a relative length. I'm actually not sure now that you mention it. That's weird. Okie dokie. So let's go to the next video where we're going to look at data structures. Okay, so I'm going to go back here and I'm going to save this file. I'm going to save this file and I'm going to create a new one, and I'm going to write here. So, nope. Data structures in Grasshopper. All right. I actually don't like that. I would like to say elements of data structures. It's fine. Is it fine? No, it's not fine. It's not fine. I don't want that. I would like to wait. Wait, so data structures in Grasshopper. Okay, so and then I can do another one, which is going to be elements, and then the next one is going to be data trees. All right, data trees. Oh no, data trees. Then the second one is going to be branches. And then the third one is going to be paths. These are all the things that we're going to define. And then fourth is going to be items. The next one is going to be indices. And then the last one is going to be lists. All right. I'm going to write here definitions. Okay. All right, so that's going to be so that's going to be one thing. I'm going to create another one. This one is going to be, I'm going to create a new file. This one is going to be what it's going to be. It's going to be called 5.2 data structures in Grasshopper. And then I'm going to create a new one here, which is going to be, can I open something with a surface? Yes, can I open this? I'm just going to delete this and save as on my desktop, save as data structures in Grasshopper. I don't even know where am I saving these files? Oh, okay. Okay, save as. Okay. Okay. That should not be there, but whatever. Wireframe. Okay, so I'm just going to okay, just going to play with the surface a little bit, and then okay, but that is not a nice surface. All right, stop. I'm procrastinating here. And then I have a surface that I have here, and then I have a couple sliders, and then I'm going to subdivide this surface into I'm going to 4 and 3, 5 and 3, for example. Yes, I think, and then I'm going to drop here this component. I'll probably want to do it the other way around. 2 and 4. Okay, and then what is the other, the numerical display? I'm going to do vector point list. And for the size, I'm just going to do, for example, something like this. Oh, this is new. They have different colors. That's kind of nice. Huh. This is an improvement. I like that. Hi, Parisa. Welcome. Good to see you. Okay, so this is what I would like to go. But I can do that actually a little farther down as soon as I explain. Something like this. Yes. And I can explain this here. Okay, I think this is probably where I want to. This is probably where I want to. Data structures in Grasshopper. Actually, let me save this in the right folder, because otherwise. Okay, and then this needs to go. I'm going to pause Dropbox. It's going to fly away. Okay. All right, so let's explain this. Oh, and I need to turn this off and off and off. And all right, so I think we can start. Wait, is this the new video? Yes. So I'm going to start here. Okay. What? Okay. All right. Hi, this is Jose Luis, and welcome to another video on the in the Introduction to Parametric Modeling series, where I'm going to talk about what data structures are inside of Grasshopper. Okay, if you remember from the previous video, I did an example where we were trying to model something, but the result of the modeling was not exactly what we wanted. So make sure you check that video to understand the context of where we are on this one. And before I figure out the solution to that, I wanted to run some definitions about how data is handled inside of Grasshopper. Okay, so before I actually go into the definitions, let's take a look at this very quick example. I have in my Rhino, I have created a surface that I am going to be using for some kind of design purpose. And I did take that surface and brought it inside of Grasshopper. So now I can use it here. I have it as input data. And I have also dropped a couple of sliders that are integers. Okay. What I'm going to do now is I'm going to subdivide this surface into a family of points in the u directions and in the v direction of the surface. Very similar to how we did it in the previous exercise, the Berlin Holocaust Memorial. So the way I'm going to do that is with this component that we already are familiar with, which is inside of surface. I'm going to divide the surface into a grid of UV points. So I'm going to place this component, I'm going to plug in the surface, and then I'm going to plug in how many divisions in the U direction and how many divisions in the V direction do I want. And you can see that I now have like 5 points in the V direction and I have 3 points in the U direction. Remember that this corresponds to divisions, not the amount of points. So if we divide the surface in 2 segments, we will get 3 points. And if we divide this surface into 4 segments, we will get 5 points in that direction. Okay? All right, so this is great. But then what I would like us to take a closer look now is into what is coming out of the point output of the component. And for that, I'm going to plug in a panel and I'm going to plug into this panel here, and then I'm going to extend this a little bigger. And in previous exercises, we had seen how the outputs of some components are not just the data itself, but for some reason, this component has some kind of like subdivision into 3 sections, and each one of the sections has like 5 elements inside of it, and then there's this weird thing here that is like zeros and ones and subdivided with semicolons, which is kind of strange. We hadn't really ever taken a close look at what that means, which is what we're going to do right now. So the way data is handled in Grasshopper is by using a very, very specific data structure that is particular to Grasshopper in particular, which is called data trees. Okay, some other systems or other parametric modeling environments have other ways of handling data. So most of the stuff that I'm going to explain today is going to be particular to Grasshopper, but also many of the ideas that I'm going to explain are also generalizable to other environments. So what are data trees? Data trees are complex data structures where the information that is contained in the structure is subdivided in a tree-like manner. What that means is that the data is just not simply all there to be up for grabs, but it has some kind of hierarchy and some kind of structure to it. So the idea behind that is that, in particular, what we're seeing right now on this panel is that this panel contains roughly 15 elements, which correspond to the 15 points that we have here, but they are subdivided into categories. And what is each one of those categories? Well, it turns out that the main components of a data tree are the branches. So what gives data trees a hierarchy, as if imagine the data tree like blooming out into multiple branches. So data in a data tree is typically grouped under branches. And branches are like different branches, I don't really know what other word to use here, are different branches of are different groupings of how the data can be structured in this overall tree. Okay, so what we can see, for example, is that if we have 15 points on our surface, we can see that that the tree is subdivided into 3 branches, each one of them containing 5 elements, which is kind of makes sense given the fact that we have 3 subdivisions in the 3 points, 3 families of points in the u direction, and then each one of them containing 5 points in the v direction. So that kind of makes sense. So for some reason, this component decides to, instead of just giving you the 15 points right away, it decides to group them into 3 groups of 5 elements, which is kind of nice for the reasons that we will see very soon. But before we go any further, let's take a look at something else that is part of the branches. If you look, branches are basically indicated in panels by using this gray separator between them, and we can see how each one of them contains the elements. But at the same time, we can see that there is some kind of numerical indicator here that corresponds to the branch itself. So what is that? Well, it turns out that branches have what's called paths, and path is basically a way of indicating a unique identifier that can differentiate that path from any other path. The idea is that if we had a very complex data tree and for some reason we just wanted to retrieve or cherry pick one of the branches, we could use the path, which refers to as which is basically the name of that branch. We could use that path to fetch or to retrieve only that branch and therefore only the elements inside of that branch. But also but you also may wonder like, oh, but why we do have like 3 different numbers and like why are the first ones always zeros and only the last one changes? Well, that is related to the data tree metaphor and the idea that that a data tree is actually the result of like several chained operations, each one of which may actually be branching out the data into more and different branches. So what this means in a very metaphorical way is that the data that we have is coming from two processes that maintain the data under the same branch. And then in the third process, in the third level, that's when the data branched out into 3 different branches. That is kind of what this path with 3 different levels, and with the first 2 levels being 0 for all the branches and the last level being different from each branch, that's kind of what it means. Okay? This is a very simple process, so that's why this tree is very simple. But when you get more complex and when you have done a lot of operations sequentially over a data set, then data trees can get much more complicated and much more rich, if you will. A way of looking at that data structure is by using the parameter viewer, which if I plug in here and I double click, you can see that I can kind of see that metaphor represented with this tiny tree. First operation is common, second operation was common to all the data, and in the third operation, the data branched out. Okay? Alrighty. And so these were paths. Now, another thing to remember, is that path IDs are unique. So there cannot be 2 branches on the same tree sharing the same branch name. If that was the case, and if we actually joined two trees that had branches with the same name, the elements in the branches with the same name will combine into a branch with that name that would have the elements for the two branches. Okay, so branch names are unique. What it's not guaranteed is that branch names have to be sequential. If you do data manipulation, you can kind of eliminate this branch here, and then we may have a branch that starts 0, 0, 0, and then the next one is 0, 0, 2. And we might be combined with another branch that is just the 0, or another branch that has 5 or 6 levels on the same data tree. So data trees and branches don't need to be homogeneous in their structure, and their names don't need to be sequential. That can vary. Okay. Last, not even close to last. So every branch in my data tree has a lot of different elements. So this branch has 5 elements, this branch has 5 elements, and this branch has 5 elements. The elements are the actual data that the tree is containing. And because they are separated in branches, each branch has a collection of data. In this case, the data is 3-dimensional points in the space, in the Rhino space or in the Grasshopper space. So each one of the elements that is contained in a branch is typically referred to as elements, or in the case of Grasshopper, you will very often find the word item to refer to each one of the elements on a branch. So items, whenever you see the word item in Grasshopper, it basically means a single element inside of a data tree. Okay? That element can be a number, can be a string, can be a point, can be a vector, can be a surface, whatever. But an item is one single element which is part of a full data tree. Okay? Now, another property that is very important, this is extremely important, is that you can notice how elements inside of a particular branch, they are ordered. There is a sequence to how they are ordered inside of the branch. This is the first one, the second one, the third one, the fourth one, and the fifth one. And you can also notice that in front of the elements, there is this number that is indicating the position of each one of these items inside of its branch. This number is extremely important, and that number is typically referred to as the index number. And that index number, index is the word that is used in Grasshopper, but it's also a word that is very commonly used in computer science in general to refer to the number that indicates the position of an element inside of a collection of elements. All right? Indices are super important because they give us a way of pinpointing to a particular element inside of a collection. So very often we will want to retrieve just the first element of a collection, the second element of a collection, the third element, etc. All right? Now, I want you, and this is super important as well, I want you to realize how very particularly, and this might come across as a little weird if you don't have programming experience, but it turns out that the first element of the branches inside of Grasshopper is not element number 1. It's actually element number 0. And the last element from a collection of 5 is not element in position 5, it's element in position 4, due to the fact that we started counting with the index number 0. So in Grasshopper and in most programming languages that I know of, the index number for collections or lists of elements always starts with 0. And this is 100% true in Grasshopper, and it's also the case in pretty much any programming language that I can think of. So we always start counting elements with the number 0. And this can be a little confusing at first. We need to keep that in mind. But it doesn't really take that much time to get used to it. And also, the last element of a list of n items will have the index number n minus 1. So if it's 10 elements, the last element will be element number 9, for example. Okay? Index numbers inside of a branch, as opposed to branches, index numbers always have to start at zero and are always correlative. I cannot start with 0, then go do 2, then do 7. No. It always has to be 0, 1, 2, 3, 4 until we run out of elements. Okay? Super important, 100% accurate. All right? And then the last thing that I would like to talk about is that, oh, sorry, no, I forgot. That was the wrong key. And the last thing that I would like to talk about is the fact that inside of branches, what we actually have is these elements that are typically referred to as lists. So wait, what are you talking about? Yes, well, turns out that technically speaking, a branch is the whole package of all the elements with their index numbers and the path name for that branch. However, what is included inside of the branch, just the data, is typically referred to as a list. Okay? So, and I want to highlight this very importantly because sometimes out there in forums and in people informally talking, blah, 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 whatever, sometimes people tend to refer to as a data list as all the elements that are present inside of a data tree. But strictly speaking, that is not true. Whenever we talk about lists, and very especially in Grasshopper, what we mean is each one of the collections that is inside of a branch of data. So for example, this data tree has 3 lists inside of it. Each one of them wrapped inside of a branch that has a path and with a bunch of elements that have correlative indices starting at the number 0. Okay, so the full data tree has 15 items here, but also contains 3 lists, each one of them containing 5 items. Okay. All right, so this was super important. Data trees, branches inside of data trees, the paths that are the unique names that define the branch, then the items as each one of the data points that is inside of the branch, the indices, which are the numbers that indicate the position inside of the list, and then lists as the collection of data that is inside of each one of the branches. Not the whole thing, just each one inside of each one of the branches. All right? If this wasn't clear, please take a look at the video again. All right? And I also, before I move on, I will very likely want to recommend this video by Andrew Human, The Deal with Data Trees. It's a 20-minute video where he explains the many of the topics that I just explained and makes the definitions, and he explains how data trees work. It's a really good video. So if you have the time, please make sure to check it out. Okay? Now, all right. So these are the definitions and these are the names that we're going to be using from here on to refer to the elements inside of a data tree in Grasshopper. But blah, 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 blah. What can we do with this? Why is this any useful at all? Well, let me actually bring a couple examples of how we can manipulate and how we can change the structure of these data trees to our advantage. And we're going to be doing that in the next video, which is going to be data tree operations in Grasshopper. So stay tuned for that one. See you on the next video. And if you're liking what you're seeing so far, maybe consider liking this video, subscribing to the channel, turning on notifications, etc., and all those YouTube things. Thanks a lot. This was Jose Luis. See you on the next video, and let's take a look at operations that we can do on data trees. Bye-bye. Okay, I think that came out well, right? Was that clear? Okay. All right, so I'm going to take a small break. I'll be right back. It's going to be 1 minute. 1 minute. Woohoo! Okay, where are we? Ariki. Woohoo! Uh, oh, Parisha. Oh, yeah, sure. Would you like to join the Discord server? We have a channel called Topic Suggestions, or we also have like a bunch of channels where people can post questions, and other people from the community are typically kind enough to try and help them out. So um, give it a try. If give it a try on the Discord server, I can't really take off from what we're doing right now and do that example. Okay. Um, Also, we do have a video. I actually made a video at some point in the channel about removing duplicate points. Didn't I do that? I thought I did that. No? Uh, Wait, so we have, where is, I thought duplicate, remove duplicate lines, we have a geometry gem called remove duplicate points. So you may want to, I don't know, you may want to check that one out. I'm going to paste here the link. Yes. But yeah, but we did that with C#. We didn't do it with plain Grasshopper. Hey, Shireen, how are you doing, sir? Good to see you. Terrence, hey, it's been a while. How are you doing? Aki Daki. So what are we doing next? Oh, data tree operations. All right. So, okay. All right. So what is next? Data tree, data structures in Grasshopper. Okay. So now we are going to, I'm going to hide that. I'm going to save this file, by the way, before I lose it. And then I'm going to create another one, which is going to be tree operations. It's going to be, oops. This one is going to be what? Tree operations. And then the next one is going to be flatten. And the second one is going to be graft. Okay. Mm-hmm. Okay. Data structures in Grasshopper. That's going to be one. And then we are going to save this, and we're going to be data tree operations in Grasshopper. That's going to be 2.5.3. And then this is going to be 5.3 data tree operations in Grasshopper. Okay. Oh yeah, you could not see what I was doing. All right. And oh no, wait. I forgot to. Okay. And then here, I'm going to do graft. Okay. Okay. Um, so how do I start the video now? I can start here, and then I can go back here and say, so what are going to be the main three operations that we're going to have? What are the main three operations that we're going to have? Well, the first one is going to be flatten, and let's see what that means. And then I go back to go back here, I go back here, and then I point at where. Before I do that, I'm going to drop in a component that is going to help me visualize the indices here on before I do that. So that's going to be very helpful. All right, so let's do this. Hi, this is Jose Luis again, and this is the new video on the series Intro to Parametric Modeling. And this video is coming after my previous one where I made a series of definition and I explained all the elements that are inside of a data tree in Grasshopper, and I explained what each one of them is, how they are structured, and what are the technical names that we use to refer to each one of them: the data tree, the branch, the path, each one of the items inside of a list of data, and the index numbers that we use to refer to their positions. In this video, I would like to give you the first introduction to operations that we can do at the level of the data tree to change the structure of that data tree. Because as I said in previous videos, 75% of or 90% of the problems that you're going to run into when working with data in Grasshopper, we're working with all right, okay, I need to start over again. I did not like that. Starting over. Hi, this is Jose Luis, and welcome to the new video on the series Intro to Parametric Modeling. In this video, we're coming from the previous one in which I explain what data trees are in Grasshopper, and I define some of the terms that we use to refer to the elements and the structure of a data tree, namely the data tree being the whole structure of the data, then divided into branches, each one of them with their paths, and then all the items that are inside of the lists that are contained inside of branches, and their index numbers that we use to refer to the positions of the items in their lists. So this was useful to set down the ground terms that we're going to be using to refer to these elements. But then in this video, what I would like to show you is the most basic operations that we can do at the level of data trees to change the structure of the data inside of a tree. And this is because, as I said in previous videos, 90% of the problems that you're going to run into Grasshopper, for example, when it's not doing what you expect, are probably going to be related to how data is handled and how data is matched. And from that 90%, I assure you that 75% of those are going to be solved by either one of the two operations that I'm about to explain right now in this video. But before I get into that, what I would like to do for the sake of helping us understand what's going on is that I would like to plot here on the Rhino viewport the index numbers of the points that I have inside of this data structure. The way I can do that is using a component that is inside of the display tab. And if I go to vector, I can see that there's a component called point list. What this does is that when connected to a data tree of points, it displays on the viewport their index number. It's just that right now it's super, super small because this default size is empty. So what I'm going to do is I'm going to plug in here a slider with a value of 10. And this is a little too big, but I'm just going to reduce this a little bit. And now you can see that I have this really nice display of index numbers, also colored homogeneously by branch. So I'm not sure if the black branch is the first one or the last one, but all the points, all the numbers with the same color are the same branch, which is really, really nice. So this is going to help me a lot understand what operations I'm going to be doing on this data tree. All right, so let's take a look at operations that we can perform to change the structure of a data tree. Remember, none of the operations that we're going to learn today in this video change any of the data whatsoever. The points are going to be the same, and if these were numbers, the numbers will be the same. The only thing that we're going to do is that we're going to rearrange and reshape how the tree that contains all those items is going to look like. And I will make a case in the next video about why this makes sense and why this is interesting. So, in data structures in Grasshopper, we have two main operations that we can do at the tree level. And in further videos down this playlist, I will teach you other operations that we can do just at the list level. But these ones are going to change the structure of the whole tree. And the first one that I would like to talk about is the one of the most important ones, which is called flatten. Okay? What does that mean? If I go to the tree tab here, to the sets tab, you can see that I have a bunch of components that work with data. And if I go to the tree category, you can see that I have a lot of components that also change the structure of a data tree. Sorry, I need to pick up a call. It might be important. All right. Okay. Uh, sorry for that. But I had been on hold for 3 hours for a problem that I had with a flight that I needed to change whatever, and I was on a hold for 3 hours with the wait with the airline, and they just called me back. So it was kind of important. Thank you for your patience. Now, where were we? What was I saying when I stopped? Can someone remind me of what was I saying right before I stopped? I think I was saying I think I was saying that I was basically going through all the components that are here, right? So I was like saying like there's a bunch of components. There's a bunch of components that operate with the tree with the data at the tree level. Okay, so yes, I'm going to pick it up from there. Thank you for your patience. I was on hold with the airline yesterday for 6.5 hours, and then they hang up on me. Yeah, I was very annoyed. All right, so where was I? Yeah. And as you can see in the tree category, we have a lot of components here that work and do different operations with the tree of data. So I'm going to drop the very one here that is called flatten tree. And you can see that the icon is kind of a tree trunk that has been chopped down. All right, which is very indicative of what this operation does. What flattening a data tree does is that it basically removes all the tree information, all the branch information. It cuts down all the complexity of the data structure, and it leaves the data structure in the simplest form possible, which is one branch with the simplest name possible, which is 0, and then all the items one after the other together after that list in one single list. So for example, let's see how that looks like. I'm going to take that data and I'm going to flatten that data tree. And then what I'm going to do is I'm going to copy paste this panel and paste another flattened and paste the flattened data right next door. So what we can see is that after the flattening operation, the data is exactly the same. All the points are the same points. They have not changed in three-dimensional space. The only thing that has happened is that I have removed all the branches and blah, 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 and now I only have one branch with the number 0 on it, the simplest possible branch ever. And then all the elements are now contained in that branch in one single list, and respecting the order in which they were in the original data tree, but they have new index numbers, because remember, the index number always has to start at 0 and has to be correlative, sequential, one after the other. So now the index number of these points are from 0 to 14, because I have 15 elements. So flattening removes all the complexity of a data tree and creates the simplest data tree that we can have, which is one tree, one list with all the elements one after the other in a branch called 0. And if I actually want to see what that looks like with these indicators, what I can do now is I can plug in the flattened tree to the point list visualizer, and you can see that now I don't have 3 branches anymore. Now I have only one black branch of points, and all the index numbers go from 0, 1, 2, 3, 4, 5, 6, 7, and 10, 14. So this is the order now in which my points are contained inside of this particular data tree. This is still a data tree. It's just the simplest possible one. All right. So yes, so that is flattening data trees. Now, what am I going to say now? I'm going to say, what am I going to say? Well, I have to now explain graph. Thank you, Ali. I have to explain graph. So, and how am I going to segue into that? So now I can just say, let's take a look at what the other option, or the other option is the opposite, is the inverse. Okay. Now, let's take a look at the other operation that is extremely important and fundamental to data tree manipulation, which is going to be an operation called graft. Okay? Graft in English means like injecting new branches inside of a tree. And if I go to my sets tab and to my tree category, you can see that I have a component here that is called graft tree, and that the icon is kind of like this this icon where like new branches are sprouting out of the tree, which is very indicative also of what this component does. Graft, in a way, we can be thought of as the opposite operation to flattening. So whereas flattening was taking the tree and removing all the complexity and making it the simplest possible tree, grafting is kind of the opposite. What grafting does is it takes a data tree and then it creates another data tree with more branches, with actually one branch per item, adding a new level to the tree, to the levels of the branches, and therefore creating the most complex data tree that can be created from that original one, aka one with one branch per item. All right, let's take a look at what that looks like. So I'm going to go back to pointless being my original surface, and I'm going to move, how am I going to do this? I'm just going to move this a little bit out of the way right now. So what I'm going to do is I'm going to plug in here graph tree, and then I'm going to copy and paste my panel, and then I'm going to plug it in here. So what you can see now is that the result of the grafting operation is that, again, I still have the exact same elements, but you can see that this operation has created a new data tree that has one more level of depth. So it has added one more number to the 3 levels that I had in the original one. So 000, 001, 002, 003, and 004. And then each one of these branches has one of the elements of the original tree. So what has happened is that all these elements that were in the branch 000 with indices 0, 1, 2, 3, and 4 are now into the branches 000, 0, 1, 2, 3, and 4. And each one of them is element 0 within that list. And the same goes for the elements that were in branch 001. Now they are element 001 and then 0, 1, 2, 3, and 4. All right. And if I use the previous component that I showed you before, I can plug this in here, and I can double click, and you can see that the tree was 3 branches, and now each one of the branches has exploded into 5 branches of its own. All right. So you can see the difference between, and if I plug in the point list, you can see that now what I'm going to get is 15 different branches, so 15 different colors for each one of these elements. And each one of those colors, each one of those items is going to be item number 0 inside of its branch. So I have now 15 different lists, each one of them with one item. Okay. All right. So that is in comparison with flattening, which was the other operation that just removed all the complexity. So this is a regular tree, this is a grafted tree, and this is a flattened tree. These two operations, flattening and grafting, are going to be the bread and butter of your data tree manipulations inside of Grasshopper. They're like the MVPs and they're used like all the time. They're so popular that actually, if you right click on the inputs or on the outputs of any component, any regular component, you have the option right away to flatten or to graft whatever is coming into the component. Or for example, you can see how this component is giving us, a tree that has 5 elements per branch. I can right click here and choose to flatten the output. And therefore what it gives me has already been pre-flattened. Or I can choose to graft, and instead of that, what I get is a tree that has been pre-grafted from there on. If you ask me, I personally don't like using these shortcuts because if you flatten or if you graft the data that is coming out of a component, then you lose the possibility of using the data without being grafted or branched. So I'm pretty old school, and I actually like using the components also because it gives me a visual indication better than the icon, but most importantly because it gives me the option to always choose whether if I want to work with the data pre-flattened, pre-graphed, or whatever. All right. So this is just a particular preference of mine. And now I have a small conceptual question that I want to throw here at you, the viewer of this video, or the person who is trying to learn algorithmic modeling. In very general terms, all right? And with many exceptions. This is definitely not a rule of thumb, but super general. If you were to choose which kind of operation would you like to favor in general in your computational design life? In general, do you want to be a person who grafts data more than flattens data? Or do you think flatten will in general be a better approach than grafting data? In general, what do you think could be a good approach? Again, with many exceptions and always based on the case of what you're doing. Give it a minute thought. Pause this video, think about it. What do you think? Well, again, with many exceptions and with many, depending on the case of what you're doing. But I would like to suggest to you that in general, whenever you can try to avoid flattening, and whenever you can try to favor grafting data, that is probably going to be in your advantage. Why is this the case? Well, when we're beginning, we may feel inclined to flatten the data all the time because it gives us a data tree that is simple to manipulate. It's very clean. It's just one branch, all the elements one after the other, and it feels like something that is easier to work with. However, just like with the metaphor of trees, if you have a tree that you chop completely, you chop the whole trunk and you just cut all the complexity and you leave it in the tree trunk, then regrowing or recreating all that complexity in case you may need that complexity, that richness of information farther down the line, is actually very difficult. But if you are able to maintain yourself at a higher level of information, which is going to be having all the data, but at the same time, having all this rich metadata of numbers and paths of where that data is coming from, that's always going to be super useful because simplifying and removing information and cutting out stuff is always going to be super easy to do. You can always flatten down the road. But if you somehow flatten and then at some point down in your algorithm, you for some reason you need that richness of information back for an operation. Recreating that richness is actually very difficult, and it takes a lot of time, just like having a tree grow. So that's why, in general, it may seem that the kind of information is a little daunting at first, but hopefully very soon you will get experience enough to be able to handle data trees that have all this richness of information. And if you keep that richness, then it will very, very likely be useful for you down the road at some point. And again, flattening and removing complexity is a super simple operation that you can always do. But recreating complexity is difficult and tedious. So if you do that for yourself, then you might get into trouble farther down the road. So keep this in mind. But again, there's thousands of there's like tons of exceptions. This is not a rule of thumb, and it depends always on the case that you're trying to do. All right. Well, so this was data tree operations in Grasshopper. This was flattening and grafting as the MVPs, the most valuable players when it comes to data tree manipulation. And now let's take a look at why is this useful? Why do I even want to manipulate the data tree and do these operations? Now let's circle back to the example that we did a couple videos ago, where we were trying to generate this canopy, and we were running into the problem that the curves were not being generated the way we wanted them. Let's go back to the video. Let's go back. In the next video, we're going to go back to that example and try to do data manipulation to fix that problem. Thank you very much. This was Jose Luis. If you like this video, consider liking it, consider subscribing to the channel, etc., etc. And see you on the next video. Thank you. Bye-bye. All right. All right, good. Okie dokie, so it's noon. I have to go. I have to have lunch, and then we're going to be back this afternoon. Okay? You're right, Victor. Explaining all of this in abstract is a little difficult to understand, but that's why we're going to circle back and then see how these operations actually work and why they are important. Okay? So, yes. So we're going to be back. We're going to be back at 1 p.m. my time. Okay, which is in 56 minutes because I have a meeting at 3 that I have to attend. So I'm going to have lunch, and if you're interested in seeing how we wrap this up, I will see you in the afternoon at 1 p.m. my time. So in 55 minutes from now. Thanks a lot. Have a good afternoon. See you. Bye-bye.